One getting well by the grace of Almighty Allah. Welcome to another day of learning. Welcome to Institute of Global Professional Pre-International Webinar in IGP platform. Thank you all for joining with us in this marvelous session. My lovely audience, today I am your host. I am Kamrul, coordinator of IGP from Bangladesh. Ladies and gentlemen, I am proud to be associated with IGP as a global member. And I feel honored to host this webinar, and it's my delight to welcome you all to our Institution of Global Professionals International webinar. Once again, I am thank you again all for joining with us in this marvelous session. And it's my humble request to you that you stay with us till the end. And don't forget to tag, share, and mention your friends in the comment box because your attachment allows us to do better and best services to our audience. And our mission is empower our youth. So stay with us by your support. Before we have completed our 775 webinars successfully. Now I will be presenting webinar number 776, and the topic is utilizing online tools GeoGebra. And this is our series program 9. Our series program name is 21 First Century Tools in Teaching Mathematics. And today our program name is utilizing online tools GeoGebra. Today we have a brilliant speaker from Philippines. Today our speaker name is Sarian June. He is also official host of IGP. He is a senior high school teacher 3 of Batan Academy, Department of Education from Philippines. Let's welcome our speaker to the screen.
Hello,
Hello,
Sir
sir.
Kamru. Hello. Thank you so much for having me here as a speaker. As what I mentioned by Sir Kamrul, I am also one of the hosts of the IGP. And I was requested if they can be able to have a talk about one of the most relevant topics that we will have in education. Okay?
Okay, sir. Thank you. You can start your presentation now.
Yes, sir. Please allow me to share my presentation. Hello, sir. Is my presentation visible?
Yes, sir. It's visible already. You can start now.
Okay. Good
Okay,
morning, good
sir.
afternoon, good morning, good afternoon, and good evening to the other parts of IGP community. Before I start my talk, I would like to say thank you to the IGP for giving me an opportunity to share this tool to my fellow mathematics educators from other countries. Now, I think IGP is accredited to more than 100 countries in the world. So I would like to say hi to my fellow educators who are watching at this moment, and most especially in our province of Aklan, who are tuning in to our program. Okay. Also, please allow me to acknowledge the following persons who helped me to be here today. To our former Schools Division Superintendent of Aklan, who is now in the Division of Copies, Dr. Miguel Macaposin, for approving my letter of request. And of course, special shout out to our new Schools Division Superintendent of Aklan, Dr. Feliciano Benefe Jr., to our Education Program Supervisor in Mathematics in the Division of Aklan, Dr. Edselin T. Biray, to our school principal in Batan Academy National School, Sir Joseph Neil E. Carmen, to my colleagues who are currently watching right now to support me, and of course, the full IGP community, thank you so much. Just for a disclaimer, I am not part of any company promoting GeoGebra for any monetary purpose. I am here because I believe that this tool is one of the most effective tools to teach our 21st century learners, especially in geometry. Okay, so my topic for today is all about utilizing online tool, specifically all about GeoGebra. The 21st century is a time of rapid changes, and this puts the 21st century teacher in a critical spot of mastering constantly evolving technology and digital learning tools, the same tools that our students are using every day. The world of work and communication is changing rapidly. As teachers, we need to prepare our students, our learners, with these 21st century skills they need to thrive in today's digital and globalized society. So, before I start discussing the tool that we have for today, I am going to start my discussion by discussing these 7 21st century skills because these are the basis why I am discussing this tool, which is to contribute in the development of these 21st century skills of our learners. And I think it was already discussed in the previous IGP webinar, the 21st century skills. Okay, so what are the 21st century skills? The first is the critical thinking skill. And why critical thinking skill is important? Number one, it helps to improve the decision making, it enhances problem solving ability, it refines your research skills, polishes your creativity, and stimulates curiosity. It is one of the most important 21st century skills to teach our learners is how to think critically. With so much information available online, it's crucial that young people analyze, question, and challenge what they are being told. They should remain open-minded, evaluate situations, and think outside the box when approaching tasks. Next is communication skill. Communication is the skill that many students find challenging to acquire, especially in the second language. So it's essential you to give them plenty of practice. Good communicators will not only speak English more clearly and confidently, they'll also excel outside of the class when it comes to studying, working, or traveling. Learners need to be able to express their opinions on a range of subjects, make themselves understood to others, and work well in groups. Next is collaboration skill. This skill links nicely with communication, as good collaborators work effectively with others to achieve a common goal. Learning how to take turns, respecting other people's opinion, and being a good player is vital to the success of our class. Teamwork skills will also help students when they leave school and find jobs, as many of them will have to work with people from different backgrounds or cultures. Next is creativity. Everyone has a creative side, they just might not know how it yet. It's your role as a teacher to help students explore their creativity and stimulate their imaginations. So, similar to critical thinking, students should be encouraged to think of new and innovative ways to solve problems, as well helping them in their other subjects at school. It will also benefit them when entering higher education or the workplace. Okay? The next is the cultural awareness. More than ever, we are living and working in a multicultural environment. Learners need to be able to understand differences between themselves and people from other countries who have different cultures or traditions. Developing respect and understanding for others will help students to find common ground with anyone they meet, whether it's at school or later when they are studying, working, or traveling. Okay, the next is digital literacy. Although it's getting to the point where our teenage learners have a better understanding of the digital world than we do, it's important to use technology in our class so that our students are engaged and motivated to learn. We need to remember that many of the younger generations do not know a life without Google, social media, or smartphones. It's therefore important that the way we teach reflects this. Okay? The next 21st century skill, the last but not the least, is the autonomy skill. So many young people study English because it's part of the school curriculum, or it might be that their parents have signed them up for extracurricular classes. Unfortunately, this often causes a lack of motivation among teenagers. So it's therefore important to personalize your classes. So speak to your teenage students about the benefits of learning any subject or learning your lesson and how it will help them in the future when studying, traveling, or looking for a job. Okay. So I am not going to elaborate more about this seven 21st century skills because it has been discussed already in the previous webinars. I have just enumerated this seven 21st century skills because this will be the basis why I am going to discuss this online tool in mathematics. Okay. The question is how to add 21st century skill building to your curriculum. Okay. And one way to integrate 21st century skill in our curriculum is through the use of the 21st century tools in teaching. Okay, and this will be the focus of my discussion for today. I'm going to discuss to you the basic tools of GeoGebra, where we can be able to learn in utilizing it into our own mathematics class. But before that, let us know first the history of GeoGebra and how it was started or how it was developed. Okay, so what is GeoGebra? GeoGebra is a dynamic mathematics software for teaching and learning mathematics from middle school through college level. It is as easy to use as dynamic geometry software, but also provides basic features of computer algebra systems to bridge some gaps between geometry, algebra, and calculus. GeoGebra is open source software under the JNU General Public License and freely available at www.geogebra.org. Okay, so for the benefits of everyone, you can download GeoGebra for free, or you can browse the www.geogebra.org so that you can be able to use the GeoGebra tools. Okay, so why GeoGebra? Why are we going to use GeoGebra, or why is it suggested to use GeoGebra application in our class? In the Principles and Standards for School Mathematics published by the NCTM, one of the principles states that technology is essential in teaching and learning mathematics. It influences the mathematics that is taught and enhances students' learning. Students can learn more mathematics more deeply with the appropriate and responsible use of technology. Okay. So, because our learners in the present time are being blessed with the different types of technology where they can use it in their education. They can use it in the classroom. They can use it in their communication with their classmates and even with us as educators. So we can use this technology as a tool for us to connect and communicate with them. And so that learning will take place not only in the classroom, but even in the web technology or the in the internet or in the online class. Okay, so who is the inventor of GeoGebra? So GeoGebra was invented by Marcus Hohenwarter while he was a student at the University of Salzburg in 2001. Okay, so GeoGebra was created was as part of master's thesis of Marcus Hohenwarter. Okay, so thank you so much for developing this one of the helpful tools nowadays in teaching mathematics. So GeoGebra has become the leading provider of dynamic mathematics software supporting science, technology, engineering, and mathematics or STEM education and innovations in teaching and learning worldwide. GeoGebra started to be used in the year 2002. So 1 year after it was invented. GeoGebra software was originated in the University of Salzburg. Okay, so this is the university where the inventor graduated. GeoGebra Materials was originally launched as GeoGebra Tube and in June 2011 and was renamed in 2016. Okay, so after it was invented in the year 2021, a lot of researchers, a lot of educators conducted study on the impact of GeoGebra in uh, the learner's achievement or the learner's performance. And let me give some studies that supports GeoGebra. So, a study done in Malaysia to evaluate the impact of GeoGebra in learning transformations by Bakar, Ayub, Luan, and Tarzimi in the year 2002 revealed that secondary school students achieved better results using the software. In another study, Camp in 2006 found that high ability grade 9 boys felt the lesson was interesting and students explored their learning beyond what was assigned by the teacher and were happy and engaged in the lesson using GeoGebra software. Next, Dogan in the year 2010 revealed that GeoGebra had positively affected students' learning and achievement and improved their motivation. Another study by Erhan and Andresen in 2013 also suggested that students improved their mathematics understanding after using the dynamic geometry software. Students were able to explore and form conjectures and therefore had better scores as well. Okay? So Here are the awards achieved by GeoGebra Inventor. So Archimedes in the 2016 MNU Award in category Mathematics in Hamburg, Germany. Microsoft Partner of the Year Award in 2015. Merlot Classics Award in 2013, NTLC Award in 2010, Tech Award in 2009, BET Award in 2009, SourceForge.net Community Choice Awards in 2008, AECT Distinguished Development Award in 2008 also, Learning Award in the year 2006, E-Twinning Award in 2006, Les Trophes de Libre in 2005, Comenius 2004, Learning Award in 2005, Digita 2004, Learning Award 2003, and EASA in the year 2002. Okay, so there's a lot of awards, and I was not able to include here the awards from the year 2016 to the year 2022. And because of this, we can say that the GeoGebra software has proven with the result of the different studies and the awards received. Now, it was proven that this tool is effective in enhancing mathematics teaching and learning, specifically in learning geometry. The students will be able to experience a hands on method of learning, which will have a positive effect in enabling them to understand the concepts better rather than just being passive learners. So the software also gives the teacher and students the opportunity to work through the concepts together through exploration and visualization. This encourages more interactive teacher student interactional environment where everyone works as a team to guide, help, and assist one another to reach the required goals. Okay, so let us now discuss the basic tools of GeoGebra. As what you can see on the screen, we have a lot of tools. Later on, as I am going to present the graphics view of the GeoGebra, we will be encountering this. And each tool has a pop down. Okay, so we have the first tool, we have the tool categories, the movement tools, the point tools, the special line tools, polygon tools, circle and arc tools, conic section tools, measurement tools, transformation tools, special objects tools, action object tools, and we have the general tools. But I am just going to present the tools which I think is more relevant, no, or the tools that we will be commonly using in our classroom. And to be specific, I'm going to present examples in geometry only so that we can be able to utilize all these tools that is being shown on the screen. Okay, so let me stop my sharing first, and I'm going to have a demonstration using the Chrome tab. Okay, please allow me to share again. Okay, so what you are seeing right now is the graphics view of the GeoGebra. Okay, so by the way, um, you can just search on the tab or on the Google geogebra.org/classic, and this page will appear. Okay. Okay, so let us first discuss this one. Okay. So this is what we call the move tools, and from the name itself, no, this tool is used to move objects in the graphics view. Let's say, for example, if we have let us have a circle. Okay, so you just click this tool, move, and then you click the circle, and then you can move it around. Okay, you can change position. Okay, so that is how we use a move tool. Okay, another is the point tool. Okay, so we have the point tool, and on the drop down we have point, point on object, attach or detach point, intersect, midpoint or center, complex number, extremum, and the roots. Okay, so let us discuss each of these tool under the point tool. Okay, so first is the point. So when you create a point, the cursor here, when you click it on the screen, automatically it will create a point. Okay, so this is the point. If you want to move the point, you click move and then click the point and you can move it around. Okay, so commonly it is being used in graphing. Okay, so if you're going to use it in graphing, you can use the name and the value. Okay, so the name and the value will have or it will appear, or the coordinates will appear, and then the name of the point. Okay, the next, when you create another point, so since that we have point A, the next will be, okay, let us name it. Okay, the next point will be B, and then it the coordinates will also appear. Let us have this. Okay, so you can show the axes, the X and Y axis, and you can also show the grid. Okay, so here, let us say if you want to have a point on the coordinate 3, 3. Yan. So we have C, the point C with a coordinate of 3, 3. Okay. If you want to change the color of the point, you just click move. Okay, you click the point, or you just click control if you want to select all points. Then you go to setting, or you just this one, and then you can click the color that you want. Okay, so say red or green. Okay, so that's how easy. Okay, or you can choose the color that you want here. Okay, next is, okay, by the way, let's have, okay, so we can also create a point between two intersecting lines. So let's say, for example, we have a line from A to B, and we have another line. Okay, so you can create a point of intersection by clicking that the point that place where the two lines intersect. Okay, and you can move the line, and wherever you move the line, that point E, which is the point of intersection, will still be the point of intersection between the two lines. Okay, next is the point on object. Okay, so let us say we have a polygon, we have a triangle. To use this point on object, we can click point on object, and then we point it inside. Okay, we click inside the polygon. Okay, we click move and let us observe what will happen to the point if we're going to try to move it outside. Okay, so if we move the point outside, it will not go outside. It will just move inside the polygon until, okay, to the boundary. Okay, yan. It will only trace the perimeter of the polygon, or it can freely move inside, but it is bounded by the sides of this polygon. Okay, next is attach and detach. So if you want to detach the point, if you want to detach this point if you want this to go outside, so you just click detach and then click the point. Okay, so click move and you can move the point outside freely. Yan. Okay. The next is intersect. Okay. So from the word intersect, of course, there is that connection between two lines. So let's say, for example, if we have this polygon and there is a line, for example. Okay, so let us try to get the intersection. So we will just click the line and that side. Okay, and we have point F as their point of intersection. On the other side also, we can just click the line and also the side where that line intersects. And we have point G as their point of intersection. Okay? If you're going to move that line, that point of intersection stay. And point F and point G will still be their intersection. Okay, so that is how we use the intersection tool. Next is the midpoint. Okay. For the midpoint, we need a midpoint or a center. Let's say we have a segment from point A to point B. Okay, so we will just click midpoint or center, and then we click the line, and the midpoint C will appear. Okay, so when we say midpoint, that divides the line into two equal parts. So if you want to check if it is really correct, if it is really the midpoint, we can use the measurement tool. Okay, we will measure the distance from C to A. Okay, so we have CA is 6.51. We can also use a measure from C to B to check if they are equal. Okay, so CA is 6.51 and CB is equal to 6.51. So it is really, point C is really the midpoint of the segment. Okay. So by the way, I am selecting, yeah, I click move and then I'm going to click Control A to select all the objects on the screen, and then I'm going to press delete and everything will be arranged. Or you can also use this tool on the graphics view tool. We have to delete everything. Yeah. Okay. Next is we have on the midpoint or the center tool, you can also use the ellipse, for example. We have, yeah, let's say we have an ellipse here. Okay, so to get the center of this ellipse, we will just click midpoint or center and then we click the ellipse. And we have point D as the center of the conic section. Okay, so that's how easy. Next tool under the point tool is complex number tool. So we will just click into the graphics view in order to create a new complex number. Okay, the value of the complex number point is fixed when the mouse button is released. Okay, so I am just going to show you how it works. So you just click complex number and then you click. So that's we have one of the complex number is Z. It's named as Z1. Okay. Next is Z2, Z3, and Z4. Okay. So it is being used in algebra. Next is we have the Extremum tool. So click on a function to find its local extrema. For polynomials, or all local extrema are found. For other functions, only those between left and right edge of the graphics view. Okay, let me show to you. Okay, let's have this one. Okay, so let's say we have y equals. Okay, let us show the graph of y equals sine x. Let us show first the grid lines. Okay, what you are seeing is the graph of line of sine y is equal to sine x. Okay, I'm going to use the extremum tool, and I want you to observe how it is useful. I'm going to click extremum, and then I am going to click the graph. Okay, so we have here A, B, C, D, E, F, G. And as we all know that it is extended to left and right. So what you are seeing on the screen is just part of the graph of y is equal to sine x. Okay, this is just part of the graph. Okay, so on the left side, you can see point A has a coordinate of negative 7.85, negative 1. B is negative 0.71, positive 1. Okay. Let us show the coordinates of the points here. Okay, so on the left side, we have 1, negative 1 as its extremum. We can see that the extremum is the highest value and the lowest value of the y coordinate. Okay, so again, it is being used in algebra. Okay, so when you are teaching functions, this will be a helpful tool. Okay, the next tool is the roots. Okay, sorry for the delay. Okay. Okay, the next tool is we have the roots tool. Okay, the roots tool is we will just click on a function tool to find its roots. For polynomial, all roots are found. For other functions, only those between left and right edge of the graphics view. So let's say, for example, if we have y is equal to x squared plus 4x plus 4. Okay. So let's say, for example, if we have y is equal to x squared plus 4x plus 4. So how roots tool is being used? So from the term roots, it will show to us the root of the function. Okay, so we will just click roots and then click the function or the graph of the function, and it will show us the root of that particular function. And as what we can see on the screen, the root is negative 2. Okay, so it's very simple. Okay, so let's proceed to another tool. The tool is line tools. Okay, so we have here. Okay, so let us use the line tool. Okay, so first is how to create a line. It's very simple. You just click line and then you point it to the screen and another point to a direction where you want to uh, point the line. Okay, so we will just have A, B, line A, B. Okay, next is we have a segment. Segment is just a subset of a line. So you just click sub segment, and then we have point A, C to point D. Okay, that's how simple. Okay, you just click move, and then you can rotate the object. Okay, you can do like this. Next tool is segment with given length. Okay, so to do this, we will just have to click segment with a given length and then click on the screen, and we will just type in centimeters, let's say 10 centimeters. Okay, so we will have from line segment EF with, okay, line segment EF with a measure of 10 centimeters. If you want to make it sure if it is really 10 centimeters, you can click uh, measurement tool, click distance or length, and then you click the line. Okay, so we have here 10 as the measure of that particular segment. Okay, the next tool, the next tool is ray. Okay, so it's you just have to click ray, then point, and another one side is in extended going to infinity. Okay, so that is array. Okay, sorry for the delay. Okay, next is we have a polyline. Okay, so how does a polyline work? Okay, so we will just click polyline and then we will just click to create a polygon, supposed to be, and we connect it to the first point or the first starting point. Okay, so as what you can see from the word polyline, meaning many lines. So we have A, B, B, C, C, D, and D, E. Okay, so it is composed of many lines. It is not a polygon. Okay, you can create as many as like this. But once you connect it back to the starting point, it will become an open, a figure. So it is not a polygon. It is a polyline only. Okay. The next tool is vector. Okay, so to select, we will just select the starting point and then the end of the point of the vector. So commonly it is being used in geometry, no, especially in the reflection and transformation. So it's very simple. We will just click vector and then a point and going to the direction where you want the vector is facing. Okay, so that is the vector. Next tool is vector from a point. So select a point A and a vector V to create the new point B. Okay, so it will just be the same as the vector. Okay, so we will proceed to the special line tools. Okay, as what you can see on the screen, when you click this icon, the drop down will have perpendicular line tool, parallel line tool, perpendicular bisector, angle bisector, tangents, polar diameter line, best fit line, or the locus. Okay, so if you can see, all these tools or all these terms are commonly used in and geometry, right? And it will be a very helpful tool for us to use this tool because we will not be anymore using chalk or any other writing tools in our classroom. We will just use this technology in our classroom. We will just need a an overhead projector or a television where our students can see what we are presenting. Okay, so let us start from perpendicular line tool. So let us say, for example, we have a line. Okay, so to make a perpendicular line out of this line, we will just click perpendicular. We will click the line, and we will have that perpendicular line already. Okay, if you want to check, because perpendicular line or perpendicular lines form a 90-degree angle. If you want to check if it is really 90 degree or 90 degrees, we will just click angle and then we select the two lines. Okay, sorry. We will click angle and we select two lines. Okay, so the angle formed is really 90 degrees. So that is how perpendicular line tool is being used. Okay, next is parallel line. Okay, I'm going to how to create a parallel line from this line AB. So we will just click the icon, special line tool, and then we will click choose parallel line, and we will click the line, and here is the line parallel to that line. Okay. You can, if you want to check if they are parallel, you can move the other line towards the other, and you will see that they will coincide. That means that they are parallel. Another way to check if they are parallel is that we can use or we can click measurement, we click slope, because in geometry, two lines are parallel if their slopes are equal. So we will click this. Okay, so we have, I'm sorry. Let me change. Let me change the line. Okay, para mas. Let's have a line like this. Okay, we click parallel line and we click the line to make another parallel line. To check if they are really parallel, we will click measurement angle and we click slope. We click the line and the slope will be displayed here. Okay, let us move. Okay, so the slope m is equal to 0.43. Let us click measurement tool and then slope, and we click again the other line and check if their slopes are the same. Okay, so we can see that m, which is equal to 0.43, is equal to m sub 1, which is also equal to 0.43. So they are parallel. So when we discuss it to our students, when we are talking about parallel lines, it will be supported with illustrations, and at the same time, we have values. So it is not enough that we tell our students that the slopes or the two lines are parallel if their slopes are equal. It will be helpful for uh, to our students to see it, to visualize it. How does lines or how do two lines having the same slope look like? And we can show it to them. Okay? So again, if their slopes are equal, when you move them towards each other, the two lines will coincide. And that is one of the properties of a parallel line. Okay, next is perpendicular bisector. So let us say, for example, we have a line segment. Okay? So we can create a perpendicular bisector from the line segment AB. From the word bisector, it means it should bisect line segment AB into two equal parts. And knowing that it is a perpendicular bisector, it should form a 90-degree angle. Okay. So we will just click special line tool. We choose a perpendicular bisector. And then we click the line. Sorry. Select 2 points on the line. Okay, so we can see that the line AB or the line segment AB is divided into two parts by another line. Okay, so we can use the Intersect tool so that we can be able to identify their point of intersection. Okay, so to check if CA is equal to CB, let us use the distance or length tool to check if it really bisects the line. So CA is equal to 5.18. Let us click CB. Okay. So as what you can see, that the two lines, segment AC and line segment CB, are equal. So that means that the line bisect line segment AB into two equal parts. Okay. Another one. Since it is named as perpendicular bisector, does it form a 90-degree angle? Let us use the measurement tool for the angle. We click the line or two sides. Okay, sorry. Okay. So as what you can see on the screen, that the two lines is forming a 90-degree angle. So it is how perpendicular bisector is used in GeoGebra. Okay. The next tool is we have angle bisector. Okay, so let's say, for example, if we have this okay, we have a 90-degree angle. To use the angle bisector, we select 3 points. Okay, so we need 3 points. Let's try to use these two lines. Yeah. So all the lines there bisect the angle, 90-degree. Okay. Let's have another one. If we're going to use the angle bisector from B to C to A. Now, from the term bisector, it should divide the 90-degree angle into two equal angles, which is 90 divided by 2 is equal to 45. Okay, let us try to measure the angle. Sorry. Okay, so let's check. Okay, the angle is equal to 45 degrees. Okay, let us also measure this angle. We have this side and that side. And let's see if it is also equal to 45 degrees. Okay, so we have the angles 45 degrees and the other one which is also equal to 45 degrees. When you add them, that will be equal to 90 degrees, which is forming a perpendicular angle. Okay. Next is tangents. Okay. When we are discussing about circles, we will be using this tool. So allow me to show. Let us see, for example, if we have circle. And we have a point outside. Okay? So selecting a point and a connect produces all tangents through the point to the conic. So we have the exterior point with a C. We will draw a tangent line from that point C going to the circle. So we will click, okay? To use that tool, we will just choose tangent. We will click the point and we will click the circle. Okay. And as what we can see, there are two tangent lines. Okay. Tangent line touches the circle at exactly 1 point. Okay. So every line touches the circle at exactly 1 point. So we can use the intersect tool. We will click the line and the circle, and we can see that there is only one intersecting, or there is only one point where the line and the circle intersect. The same thing, we can click the line and we can also click the circle. Okay, so we have point D and point E as the tangent point or the point of tangency between the two lines coming from the exterior point C. Okay, so if you're going to move C, okay, if you're going to move it around, okay, there, later on I'm going to show also the theorems or visualizing the theorems of circle. Okay. You can also, okay, you can click the line, then show trace. You can color it as blue. You can also trace. You can color it red, and then you can move the point around the circle and see what will happen. Okay. Okay. So it will create an effect. So that point of tangency will only touches the outside part of the circle. It will not come in. Now, students will see that the point of tangency is just roaming or circling around the circumference of the circle. It cannot be going inside the circle as what being shown in the screen as we trace the lines. Okay. Okay. Sorry for the delay. Okay, the next tool that we're going to discuss is Okay, the next tool is about polar or diameter line. In geometry, a pole and a polar are respectively a point and a line that have a unique reciprocal relationship with respect to a given conic section. So, polar reciprocation in a given circle is the transformation of each point in the plane into its polar line and each line in the plane into its pole. So to do this, we select a line or a vector and a conic section to get the conjugate diameter of the diameter parallel to the given line or vector relative to the given conic. Okay, so let me show it. So let's say, for example, if I have a circle and I have a line. Okay, so to use the polar line or diameter line, we will just need a circle and then we will just have a diameter. And then we click polar or diameter line, we click the line and then we click the circle. Okay. So in geometry, two diameters of a conic section are said to be conjugate if each chord perpendicular to one diameter is bisected by another diameter. So for example, two diameters of a circle are conjugate if and only if they are perpendicular. So let us check if the two diameters, so from this point here going to here, are perpendicular. Okay. So let us measure the line, the angle from this point, this line going to this line. Measurement tool going to the angle and then select the line and the other line. Okay. Okay. So it forms a 90-degree angle. So that's how polar or diameter line works. Okay. So next is, let's proceed, polygon. Very common in either in secondary or in elementary. Okay, so we have here a polygon. We'll just click anywhere on the screen and you can make a polygon with as many points or as many corners, as many sides that you want. Okay, so that is an example of this polygon tool here. Next, we have a regular polygon. For making this regular polygon, we will just click a regular polygon on the icon and then we click one point and another point and then you're you are going to ask how many vertices or how many sides you will have. Let's say 10. Okay, let's say 10 vertices. Click OK. Okay, so I think I am having an internet problem. Okay, so regular polygon, meaning all sides are equal. Now, let's check if it is really true. Okay, so it's not enough. Again, not just like what I said a while ago, it is not enough that we tell our students that regular polygon are polygons whose sides are all equal in measure. Okay, so with this 10 side polygon on the screen, we will be showing to our students that each side of this polygon is equal. So we will measure one of the sides. Okay, the measure is 7.57. By clicking all the sides, okay, 7.57 also. Okay, so students can see that it is really a regular polygon. Okay, so all sides measure 7.51 centimeters. Okay, the next tool is the rigid polygon. We will just click rigid polygon and then we will click, let's say for example, if we're going to, okay, we have a triangle. Okay, one of the points here, okay, there are only 2 points. Because in the rigid polygon, we can rotate the figure that we made. Okay? So you can move 1 point to rotate the figure that we made. Okay? And the other point is used to change position or place on the screen or in moving the object. Okay? That is how it works. Rigid polygon. Okay? Next tool is the vector polygon. I'm going to select 3 points. Okay. So by moving again, okay, so you can reshape the figure that you made. Okay. That's how different it differs to the rigid polygon that we have a while ago. Okay. So um, the next part that I will be discussing is I'm going to show how are we going to we're going to make simple illustrations in our class in geometry using the properties of the figures or shapes that we are discussing to our students. Let's say, for example, how to create an equilateral triangle. Okay, equilateral triangle is a triangle with three sides are equal. So you can use a regular polygon. We have, okay, we will just have like this. Okay, so the three sides here are expected to be equal. Let's check. Let's check. Let us check the distance of each side. 20.45, 20.45. The other one is also 20.45. Okay? So if you move it, as you make one of the sides larger, the other two sides are adjusting. Okay? Because it was defined as regular polygon or equilateral triangle. Okay? So the properties is being preserved. Okay? So no matter how small, how big the triangle is, if it is defined as equilateral triangle, all sides must be equal. Okay. Another way to um, create in an equilateral triangle is to use the property of circles. Okay. So let us say, for example, we have one circle. Okay. And let us create another circle with the same radius. So from point E, we will drag to point D. Okay? So we have two circles sharing the same radius. Okay. Next is to use the Intersect tool. Click the intersection or the two circles to highlight their intersection. So we have point F and point E. But since that our goal is to create an equilateral triangle, we can now join the point of intersection F going to point D and point F going to point E. Okay. So if you have noticed that we have here DE is, we have here DE here is the common radius of the two circles. And we have here DF is also a radius of circle 1, let's say for example circle 1 and circle 2. So EF is a radius of circle 1 and we have EF is a radius of circle 2. Now, if we want to check if they are really equal, let us check the line. It's 11.17, 11.77, sorry. And another is 11.77. Okay, so we can say that we have created an equilateral triangle. Okay. For the purpose of illustration, you can click the two circles and then you click hide. Okay. So we now have an equilateral triangle. You can move. Okay. As you move one of the sides or one of the points, the two other sides are adjusting, preserving the property of an equilateral triangle. Okay? So that is how we create an equilateral triangle in the GeoGebra. So it's not just enough that we draw a triangle and then we will just tell our students, okay, class, this is an equilateral triangle. It would be better if we show to them that it is really an equilateral triangle using the measurements. Okay, but by not by just telling them, but by showing to them that equilateral triangles have equal sides. Okay. Next, how are we going to create a square? Okay, so first, to create a square, we will just make a circle. Okay, let me hide the names, the coordinates. Okay, name only. So we have circle A with a radius of AB. Okay, we can create a perpendicular line by clicking the radius and a point. Okay, then we can click the intersection. Okay, click the circle and this line. Okay, so point D. Point D here is the intersection of the circle and the perpendicular line. Okay. Next, we can create another perpendicular line since that the two sides or opposite sides of a square is parallel. We can do also we can also do that. Uh, we can click parallel line. Okay, we can click parallel line. We click that line here and then we drag it towards point D. Okay, or we can click perpendicular line. We click the radius and we click point B. Okay. So from that, we can say that DA and the line that is tangent to the circle at point B is parallel because they are both perpendicular to the radius. Okay. Next is to create another perpendicular line from this line going to that point or from that point D. Okay, we can click intersect, we can click the two lines. Okay, so we now have A, B, E, D as our square. Okay, now we can now trace it using segment. We can have point D going to A going to B going to E, and E going to D. And we will just hide the other objects. So we will just click the line, the circle, the other two lines. And then we hide. Okay, so we now have square, DABE. Let's try to move one of the sides. Yeah. As we move one of the sides, all the other three sides are adjusting. Okay. If you want to justify more or to show proof that it is really a square, you can use the measurement tool to measure the distance or the length of each side. We click this side, click one side, another side, another side, and then so that students can see that the sides or the measure of each side is equal. Okay? Another property of a square is that their angles must be all 90 degrees. So we can again use the measurement tool. We click angle, and then we click two sides. And it is really equal to 90 degrees. Okay. Okay. So as what you can see on the screen, that all angles are equal to 90 degrees. So using the GeoGebra tool, we are not just making illustrations, but we are also providing numbers. We are providing measurements so that the learning that we are imparting to our students are verified and supported with illustrations, and so that students can have a concrete evidence about the concept that we are trying to discuss. So, the more pictures or visualizations that our students can see, the lesser abstract will be mathematics is, in which most of our students are, uh, so let's say, they find it difficult because of the abstraction of the concepts of mathematics. So using the visualization, or if using the pictures that we are showing to our students, it can help them to see the real picture of what we are discussing inside the classroom. Okay, next. Okay, next, how are we going to create a right triangle? So it's very simple. We click angle with given size. Okay. Then we click the angle, and then, okay, by default, it is already 90 degrees. Okay, so we have triangle A prime, B. Triangle, right angle at alpha. So let us trace using the segment. Click, or we will just connect A to B, B to A prime, and A prime to A. Okay. So as you move the triangle, it is a right triangle, right angle at B. Okay. So that's how simple. Most of the time in trigonometry, we will be dealing with right triangle. So it can also be a useful tool in discussing trigonometry. Okay. Next is how to create a rectangle. Okay, so we can, what we can do is we can create a line. Okay. Okay, so another thing, the reason why we use GeoGebra in teaching our learners is that as we discuss or as we present the picture, we are constructing the picture based on the properties of the shapes. Okay, so let's say a rectangle. Rectangle has opposite sides parallel, and whose opposite sides are parallel and equal, and whose angles are all 90 degrees. So we can construct this using those properties. So we start from a line, and then we create a perpendicular line. We click the line and that point. Okay. Next, the opposite, this side here, we will create a parallel line. Okay. We click that line, and we drag it towards the other point. Okay. Next, we can move this line here. Okay, next, we can also create another parallel line by clicking this line and then move it to the other point. Okay, and we trace it using segments by clicking the two opposite side, two consecutive points. Okay, by the way, we have to emphasize the intersection of these two lines so that, okay, so that point D is their point of intersection and that we can connect a segment from B to D and from D to C. Okay, so from that, we can now click all the unnecessary lines and we can hide them. Okay, so it is now a rectangle. Okay. Okay. So let us check if it is really a rectangle. Are all angles 90 degrees? Let's check. Okay, check. All angles are 90 degrees. What we are checking. Okay. Okay, so we have all angles are 90 degrees. So based on the properties of a rectangle, it is confirmed. Next, are the two opposite sides parallel? And we can do that by measuring the slope. Okay, wait lang. Can move. Okay, since that we are dealing with slope, okay, we click slope and then we click the line. Okay, let us move. M1 is 0.34. Let us check the opposite side if they have equal slope. Okay. M2 is equal to 0.34. So we can say that the two opposite sides are really parallel. Now, let's check the other opposite sides. We click the slope and we click the line. Okay. M3 or the slope 3 is negative 2.95. Okay, because the trend is decreasing, right? Okay, we click again. Okay, that is also negative 2.95. Okay, so the pair of opposite sides are having equal slopes. That means that based on the property of rectangle, this is really a rectangle. Okay, it is confirmed that it is a rectangle. Okay. Okay, so I think that is the only thing that I can be able to share with uh, the IGP community, and I hope that you have learned something from my discussion. I have a lot, supposed to be, I have a lot of things to be demonstrated, but due to time constraint, maybe I can just reserve this. And I am challenging all mathematics educators to explore not only GeoGebra but also the other tools that we can use in our class. And maybe someday you can also be one of the speakers that can also share what you have learned by the exploration that you have. Okay, so thank you so much, IGP, and thank you so much to our uh, viewers and audiences that really waited until the end of this program. Sir? Okay, hello, sir. Kamrul?
Thank you, Sir Yanjun, for your wonderful presentation about your GeoGebra. Thank you, sir.
Thank you so much, also, sir.
So
Thank you
now
so
we are
much.
proceed to our quiz competition, and after that we come back again with our Q&A session. Okay, sir?
Okay, sir.
Okay. Dear participants, now we are proceed to our quiz competition. Today our quiz code is IGP quiz. The code is IGP quiz. Let's enjoy our quiz video. Welcome back again. This is our quiz competition session time. You can join this session by slido.com. And today our quiz code is IGP. The code is IGP quiz. You can also scan our QR code from the screen to join this live quiz session. And don't forget to mention your friends in the comment box to join this session. Top 10 quiz competition winners get their quiz certificate after this session from our official Facebook page. Our Facebook page address is Institute of Global Professionals. I request everyone to join with your full name. Quiz will directly print on your quiz certificate. I remind you that there is no relationship between quiz completion certificate and international webinar certificate. And top 10 quiz competition winners get their quiz certificate after this session. We start our quiz competition now, so be ready. Our first question is, what refers to a person utilizing information for politics and government? Is it digital curriculum or digital citizenship? Option number 2, digital citizenship is the right answer. Let's move to our next question. The question is, Employers provide tools and technology for their employees in order to increase the cost of production and profitability or improve their efficiency and productivity. Option number two, improve their efficiency and productivity is the right answer. Our next question is, what is the way to see online classroom assignment? Is it Google Classroom or Google Form? Option number one, Google Classroom is the right answer. Our next question is, which of the following tools is not part of the promotional mix? Is it personal selling or product design? Option number two, product design is the right answer. Our next question is, what are the benefits of utilizing technology within the classroom? Is it provides an opportunity to watch videos all day or supports inclusivity for all students? Option number two, support inclusivity for all students is the right answer. Our next question is, which of the following is an advantage of utilizing technology? Is it technology reduce the need for a marketing plan or productivity increases? Option number two, productivity increases is the right answer. Our next question is, what are some tools to help with time management? Is it using a planner, calendar, or task-oriented list, or using the academic posting as a great way to organize yourself? Option number one, using a planner, calendar, or task-oriented list is the right answer. Our next question is, what tools should be used to motivate e-learners? Is it relevant and practical information or forums and assessment? Option number two, forums and assessment is the right answer. Our second last question is, the buying and selling of goods online, is it digital communication or digital commerce? Option number two, digital commerce is the right answer. Our last and final question is, the tools you use to secure your identity, asset, and technology in the online and mobile world. Is it digital rights or digital security? Option number 2, digital security is the right answer. Thank you everyone. On the leaderboard, now the top position is Cyril Calidria Magusi, and the second one is Pema Lajom, and the third one is Christina Tidintes, and the following Jileni Kabira, Leson Muniandi, Jamiang Lamo, Alex Xavier Alvarez, Jimuel Sagario, JB Apricio, and the last one is Evelyn P. Waiperi. Thank you everyone for participating this session. Now we are proceed to our question and answer session. So let's enjoy this video. Thank you everyone. Now this session is question and answer session. You can send your question in the comment box. Sir, our first question is, how important is the GeoGebra application to the teacher?
Okay. Once again, good afternoon. Thank you so much for the question, Sir Flomi Salviejo. Um, it is very important for a mathematics teacher to use GeoGebra because one, it can help students visualize the lesson that the teacher is discussing. One of the problems that the students are facing nowadays is that because of the abstraction of the lessons in mathematics. And to help our students visualize or to see or to translate that abstract ideas into something that they can see or they can visualize is with the use of this GeoGebra application. Okay, we are just like what I said in the discussion a while ago that we are not just going to construct shapes, but we are constructing it based on the properties, based on the definitions that we are telling to our students. So I think that is one of the reasons that why GeoGebra is important to teachers, especially to mathematics teachers.
Thank you, sir. Our next question is, what's the most challenging part in using GeoGebra in teaching?
Okay, thank you so much, Sir James Agario, for that question. Okay, if you are using GeoGebra because GeoGebra is requiring internet connection, especially if you're using GeoGebra Classroom. I think that is one of the challenges, the internet connection. So if a student or if a teacher is located into a place where internet connection is poor, then that is one of the problem that he or she might experience. But I think we have GeoGebra geometry, which we can download in our cell phone, in which our students can be able to use it offline. So even they are at home with the absence of internet connection, they can be able to use it. They can be able to utilize GeoGebra, geometry application in, let's say, answering their assignments. Okay. Another challenge for the teacher is Of course, as a teacher, you must have to be familiar with the different tools, with whatever tool that you are using. So it requires practice. It requires time and efforts so that you can be able to discuss and you can be able to impart learnings to your students with the use of GeoGebra application. That's all, sir.
Thank you, sir. Our next question is how can GeoGebra be used in classroom?
Okay. So how can GeoGebra be used in the classroom? Okay. From Justin Guy. Well, if your school is blessed with the internet connection, you can use blended learning. You can connect with your students through their cell phone or through their laptop. But in the casual or in the usual classroom setting, you can just use overhead projector. You can use television so that um, the students can clearly see what you are presenting. Okay, uh, with your laptop or with your cell phone, you can be able to discuss things with different illustrations for a better understanding of the students. And if you're using online classroom, just like Google or Zoom, you can also present. You can also present just like what I am doing today. I am presenting using the the Chrome tab, so that those students who cannot go to your to school can be or can learn something while they are at home using online teaching with the use of this platform. That's all, sir.
Thank you so much, sir, for your wonderful answer and also your presentation. It's wonderful. Thank you, sir.
Thank you also. Thank you so much, IGP, and thank you so much to the whole IGP community for watching in this wonderful session. Thank you so much.
Thank you, sir. What is your last and final word for our audience?
Again, sir.
What is your last and final word for our participants?
Yeah. Okay. Thank you so much, dear participants, and see you on August 30 because I will also be discussing another tools or another tool in teaching mathematics, and that will be about geometry's sketch one. So see you on August 30. Thank you so much.
Thank you for your invitation. Thank you, sir.
Thank you so much also, sir.
Dear participants, today our series program name is 21 First Century Tools in Teaching Mathematics, and today our webinar name is Utilizing Online Tools GeoGebra. And today our webinar code is IGP3039. The code is IGP3039. Without code, no one is eligible for certificate. With code, you can claim your certificate anytime from our website. And without an account on our website, you can visit only, but you can't do anything functionally. So to download your certificate, first of all, you have to create an account on our website. Then you have to enroll the program, and after that you have to put the code, and the code is IGP3039. After downloading your certificate, don't forget to celebrate with IGP second. Thank you everyone for participating this session. Before ending the program, I request everyone you like our Facebook page and subscribe our YouTube channel for upcoming information. Thank you everyone. Stay happy and stay safe.